Hey guys, today we're going to be analyzing quadratics and looking at their domain and ranges. So, standard form of a quadratic function, okay, we know is y equals ax squared plus bx plus c. This is something where we've seen before where a is not equal to 0. We call this standard form. Notice you have a few examples of what standard form can look like. Y equals 5x squared. Notice this one only has the letter a, right? Or it could look like y equals x squared plus 7. Notice this one only has an a and a c. Or it can look like the last one, which is y equals x squared minus x minus 3, which has the a, the b, and the c. Okay, a parabola is a U-shape graph that represents a quadratic function. So notice here I drew two examples, okay? This is a parabola that opens up. Notice it looks like a happy face. And then there's also parabolas that open down. Notice that looks like a sad face. The axis of symmetry, which is also known as the AOS, is a line that cuts the parabola into two matching halves. So notice it doesn't matter if it's a happy face, right? A parabola opening up or parabola opening down. The AOS is basically a line that you can cut right down the middle of your U shape. Now the vertex is either the highest point or the lowest point on a parabola. It's basically the middle point of your U shape. So you can notice right here our parabola's vertex for this one is right here in the center, okay, of the U, and this would be the lowest point. And notice on the other version, so when I have the sad face, I notice my vertex here is at the highest point. Now, those vertex have special names. A minimum is the vertex when it is at the lowest point. So whenever you have a happy face, your vertex is called a minimum. A maximum is a vertex when it is the highest point. So whenever you have your sad face, right, parabola opens down, your vertex is known as a maximum because that's the highest point. Just to remind you guys, we know what domain and range is. Domain represents our x values and range represents our y values. So let's look at this part. Identify the vertex and state whether it is a minimum or a maximum. Then draw the axis of symmetry in both graphs. What is the equation for each axis of symmetry, AOS? So let's go ahead and look at the first one and let's identify what is the vertex. I remember that the vertex is the point in the middle of the U and it's either the highest or the lowest. So there's my vertex and we can mark this as a point, and that point is 1, 2. Now, because this is a sad face, right, sad face, I know that that point is the highest, so that will be called a maximum. Now, remember, our AOS is a line that goes down the middle, okay? And now notice that's a vertical line. Hopefully, we remember that vertical lines always begin with x equals. So, x equals, what is the x-intercept here? And that would be 1. So that's the equation for the axis of symmetry, or the AOS. B, same concept. Let's find the vertex. I know it's the point in the middle, and it's either the highest or the lowest, and it is right here. Okay, and that point is, write it down, 2, -4. Now, if it's the lowest point, we're going to call it then the minimum. Now, axis of symmetry, let me draw the line down the middle. Okay, notice I'm cutting the U shape in half, basically. Okay, two equal halves. And I notice that the AOS is a vertical line again, so it's going to be a x equals, and it equals 2. One thing I want you guys to recognize is, notice that your AOS line always goes through your vertex, okay? It always goes through your vertex. So notice that's why we have x equals 1. You see the connection? That's why this one is x equals 2. Okay, so that's kind of a helpful hint when you have to write your AOS. Okay, now I want you guys to try these two on your own. So pause it, see if you get it right. I'm going to put the answers, so please make sure you pause it and really try this on your own. This is a really simple thing. Alright, now let us find the domain and range of the following quadratics. Just want to remind you guys, when we found domain and ranges, okay, remember that domains are our x value. So it's usually when I focus on the x-axis, okay? And we always go from the left to the right for our x-axis, okay? So notice we always put the left number first, and then on these blanks, it's usually one of the inequality signs, and you have two options. It's either going to be less than, or it could be less than or equal to, okay? It just depends. If it's on the line, then we know it's less than or equal to. If it's ever going to be infinity, right, or an open circle, that's when we use just the less than. Same idea goes with our range. Remember, our range goes from the bottom, okay, bottom to the top on our y-axis, okay? So when I write out my range, we always put the bottom number first, then it'll be either less than or equal to y, because range represents our y values. Again, less than or equal to, depending on if it's on the line or if it's infinity, okay? And finally, we end it with the top number, okay? So let's go ahead and look at this and see what we come up with. Okay, what I notice is that this line has a top limit. Okay, I'm going to put a T here. So it has a top limit. Notice, does it ever stop going from the left or the right? So if I was to continue this graph, is it ever going to stop going from left to right? No, it's not. So what that tells us is that it's going from negative infinity to positive infinity. So I'm going from negative infinity on my x to positive infinity on my x. So when I write my domain, remember we always go left first, so that's negative infinity is less than x, which is less than positive infinity. Remember, you can also write your answer in a different form, parenthesis, negative infinity, comma, infinity, close parenthesis, okay? So you can use either method, either way you prefer. Okay, still give us the same answer. Now, what does this mean if you have negative infinity to positive infinity? What it basically tells us is that the domain is all real numbers. Okay, it is all real numbers. All right, now let's find our range. Now, I notice my range here has a top number, and that's right here. And hopefully remember that that point that I just made is also known as the vertex, which in this case is a maximum because it's the highest point. And that maximum number here is 2. Now when I write out my range, remember we begin from the bottom. Now does it have a limit going to the bottom? Notice I have these arrows, so that tells me that it's going on forever in the negative infinity direction. So my range will begin with negative infinity is less than y, because it's a range, but it's less than or equal to our top number, which we identified as 2. If I want to write it in our different notation, okay, I put negative infinity, comma, 2 with a bracket. So notice our range actually does have a limit here. Now let's look for B. Same concept, looking for domain and range. What I do notice is that my range has a limit here, right? There's that vertex again. And notice it's at the bottom. But if I was to draw this graph continually going in either direction, left or right, because I'm looking for my domain first, it never stops. It never stops going to the negative infinity direction, and it never stops going to the infinity direction, left or right. So my domain, again, is going to be negative infinity to positive infinity. Notice, what does that mean? If I have two infinities, it basically means that the answer is the domain is all real numbers. Now to find the range. Range, remember, bottom to the top. The bottom does have a limit. And what is our bottom number here? Looks like it's negative 4. So negative 4 is less than or equal to y, which is less than. Does our parabola here ever stop going to the top? No, so it's going to positive infinity. So there is our range. When you have parabolas that open up or down, okay, the domain is pretty much always going to be all real numbers. So there's a little shortcut if you remember this, okay? Anytime you're asked about the domain or, just the domain of a parabola and it's opening up or down, the answer is always going to be all real numbers. One thing that I want you guys to look at is, look at our vertex. If you notice our vertex, which is this right here. And if I was to write that vertex as a point, that point would be 1, 2, right? Notice that this y value is in our answer for the range, okay? Same thing for every single one of these parabolas that you find a range for, okay? The range is always going to be that number in your vertex, okay? So if you ever need help finding a range, you can always just find the vertex and just know that the y value, because remember, the range is the y value, that number will end up being in your range answer. Now I want you to try on your own again. I will put the answer up, but please pause the video, test this out, see if you can do this on your own, okay? Hopefully we all know the answer, though, to the domain part, okay? We should all, if you remember from the previous slide, the domain for any parabola that opens up or down is always all real numbers. Suppose a squirrel is in a tree 6 feet above the ground. It drops an acorn. The function h equals negative 4t squared plus 6 gives the height of the acorn h in feet after t seconds. Create a table and a graph for this quadratic function. First thing that we're going to answer is, what is the independent variable and what is the dependent variable? So what are the two things that we're talking about here? It looks like the two things we're talking about are h in feet, which represents the height in feet, and t, which represents seconds. So of the height and seconds, which one represents our independent? Remember, independent is what happens first. It is our x value, okay? And hopefully you guys recall that time, so seconds, time, is always our independent. So that would make our dependent, which is our y value, h, which stands for the height. Okay. So let's go ahead and graph a few points here. If you guys were in class, I know that we would have typed this equation, right, into our calculators. We would have put negative 4x squared plus 6 in our calculators and then just looked at the table. So I went ahead and just did the table for you. All right, so let's go ahead and actually plot a few of those points and see if we can kind of get an idea as far as what does our parabola look like. So notice I was only able to plot 5 of the points, okay? That last point, the 2.5 comma negative 19, I can't plot it on here. So what I notice is that my parabola looks like it's going in this down motion. So this point here seems to be our vertex, which is 0, 6, okay? And what do we call that point? Is that our maximum or a minimum? Well, if this is going to be a sad face, then that point is going to be the highest, so therefore that we would call it a maximum. Now, our axis of symmetry, the line that will cut it in half, remember, we know the AOS goes through our vertex. So I know it's going to be a line cutting this parabola in half, going down through the vertex. So there is my AOS, and I can actually label it. That's going to be x equals 0, because that's what the x value is in the vertex, okay, just to remind you. Now, the domain here is going to be something a little bit special. Well, actually not really, because we already know what the answer is, right? The domain for any parabola going up or down, facing up or down, is always all real numbers, okay? The range is where we have the limitation. Now, the range, I know, will not go past that point, because that's our highest point. That's the point furthest to the top. So I know my range is going all the way down to negative infinity, is less than y, because range is y, and is less than or equal to the top number, which is the value 6, which again you can also get from your vertex, okay? Remember, you can also write this a different way, parentheses, negative infinity, comma, 6, bracket, okay? So there's your domain and range for this graph. Recall that x-intercepts are also known as two very special things. They're known as solutions, okay, or they're also known as zeros. All right, what I have here are 3 different examples, okay, and I want us to focus on where is our solutions. Where are the zeros? Where are the x-intercepts? Notice I'm going to use all three words all the time so that you guys understand that they're always the same. So in this first parabola, I noticed that the solution, okay, is right here, and there's only one solution. Okay, so we'll have situations where a parabola only gives us one solution, or in other words, one vertex. Notice this vertex is special because not only is it the vertex, but it's also an x-intercept. Okay, the next one. Notice when I look at the parabola, I see that it crosses the x-axis there and here. So therefore, there are two x-intercepts. So it has two solutions, two zeros. And finally, the last situation. Well, notice the parabola never touches the x-axis, so therefore there are no zeros, okay? I'd rather put no instead of zero. Sorry, no zeros, okay? Three different situations about x-intercepts on our parabolas. Alright, so here they want us to graph the function y equals 2x squared plus 4x minus 3. Notice if we had a calculator, we'd be able to do that. So I went ahead and did that anyways, and this is what it would look like if you had your calculator in front of you, okay? So notice I went to y equals, I typed it in, I hit graph, and then this is what my picture gives me. Now, based on looking at it, you should be able to tell me whether the vertex is a minimum or if it is a maximum, okay? Hopefully we all agree that this has a minimum, okay? So be sure to write that right here at the spot, okay? Because the vertex here is the minimum. It is the lowest point on our graph. Now, here are the list of steps to find a vertex, okay, in the calculator. So we're wanting to know what is that point, right? What is the x value and the y value of that point for our vertex, okay? So the steps are type the quadratic function in y equals. Make sure you're writing this. Number 2, look at the parabola. You must be able to see the vertex. If you can't see it, then you might need to zoom out. Then you need to ask yourself, is it a minimum or a maximum? Okay, so step 4 is you go to second trace, which we use a lot, and you pick which option you decided. Was it minimum? You pick number 3. If it was maximum, you hit number 4. Then you have to go to the left of it, hit enter. Then you have to go to the right of it, hit enter, and that's to the left and to the right of the vertex, that point in the middle, okay? And finally, you hit enter one more time, and it'll tell you what your x and y values are. Go ahead and take some time to plot these 5 points, okay? These are the same 5 points of the same parabola we were just looking at, okay? So we're still discussing the same one. So notice this is what it should look like, okay? So we're going to answer a few questions, so if you need to pause and do that and finish plotting those points, please do so. Hopefully you got a good idea as far as where those points were. Okay, so first thing we're going to do is figure out what is our vertex. It looks like our vertex is -1, -5. We would call that for sure a minimum because it's the lowest point. Okay, remember, that's what we're talking about right there. That's the vertex. Alright, the AOS, remember, it's the one that cuts this in half, and that would be the line that looks like this. And what is the equation of that line? I know it begins with x because this is a vertical line, and it's going through -1. Okay, domain, remember, we know the domain is all real numbers. Okay, now if I'm looking for my range, which is what I'm doing now, I know that I do not go past this point. That's my bottom point, which is -5. So I know my range goes to positive infinity. So positive infinity is less than y, which is less than or equal to, oh, sorry, I wrote that backwards. Can anyone figure out the mistake? What should I have begin with? Remember, we have to start from the bottom and then go to the top. Okay, so let me rewrite that. It should be -5 is less than or equal to y, which is less than to infinity. Number on top goes at the end. Okay, so what do our zeros appear to be? Remember, the word zero, okay, means x-intercept or solution. So notice it doesn't look like we have exact points, but we can make an estimation. I notice that I have 2 of them, right? Okay, clearly we see that there are 2 of them, and we're going to write them as points. And the first one that I'm going to look at is the one over here on the left side, and that looks like it's in between -2 and -3. So we're just going to say that it is -2.5, 0. And on the other side, it looks like it's going through 1 in our picture. Notice if we had this drawn out better, it may not be there, but approximately appears in our picture to be 1, 0. But here's the cool thing. If you guys had a calculator, we could actually do this part in our calculator because we've done those before already. Alright, this time I'm going to give you certain situations, and I want you to draw the quadratic based on what I tell you. First thing I tell you is that the parabola opens up, so I know that's going to be a happy face. Okay, that's the first thing I know. The next thing is that I want the axis of symmetry to be x equals 6. So I'm going to go ahead and draw that little dashed line that I've been using for the AOS. And what that tells me is that's supposed to be in the middle of it. The next part is that it's supposed to only contain one solution. Well, what does it mean by contain only one solution? In other words, it's saying it should only have one x-intercept. So where would I have to put it in order for it to have only one x-intercept? I would have to make the vertex the only x-intercept and go through there and up. And notice it should be looking like I've, created equally on both sides of the AOS. So notice, what is our vertex then? Our vertex is 6, 0. Because that creates a one solution situation on our picture. Is this a maximum, or a minimum? It is a minimum. Domain, hopefully we remember, is all real numbers. Now let's find our range. Our range, okay, I know is not going to go past this point on my y, so that's my number furthest to the bottom, which is, according to the y-axis, that's 0. And it goes on forever on top, okay, to infinity. So my range is from the bottom. 0 is less than or equal to y, which is less than infinity. So there's all the information that I need to know. Alright, last thing here, you can actually, if you want, pause the video, try this on your own. I'm just going to label the basic information. So if you think you can handle it, that's fine. So the basic information that I'm going to label is, for example, I'm going to label the vertex, the AOS. I'm going to label the solutions. Remember, solutions is, in other words, the x-intercepts. Okay. When I label the vertex, I'm going to state whether it is a min or a maximum. Okay, so just basic information you should know when you see this. I'm also going to tell you if it what direction it faces. So is it open, is it up, or is it open down? Okay, basic stuff that you should know. So that's what I want you to find. So you can pause it and do it on your own and then check back. So there's all the information, basic information that you have to know after today. You should be able to find this stuff pretty easily. Notice I didn't make you find the domain and range, but feel free to do that if you want some practice, okay? But hopefully you guys all understand how to find a vertex, determine if it's a minimum or maximum, okay? Find the AOS, the axis of symmetry, and be able to write the equation, and figure out how many solutions there are, and in other words, solutions are x-intercepts, and be able to not only tell me how many there are, but be able to tell me what they are. Peace out.